So today we are going to learn about the Moeller chart. The Moeller chart is actually used to write the electronic configuration of elements. So to first learn how to write electronic configuration of elements, you need to learn the Moeller chart. So today I am going to tell you how to draw the Moeller chart and how to use it while writing the electronic configuration. So first of all, let me just tell you what is electronic configuration in simple words. It just tells you how electrons are arranged in an atom, how many electrons are present in the first shell and how many in the second. It just gives you the values of that, and to learn those values you must be familiar with the Moeller chart. So let's start. So this is the Moeller chart. This is how it looks. So how to draw this Moeller chart in the first place? So first you need to learn about the four shells, S, P, D and F. So let me just give you a quick review on these shells. So S shell can hold up to 2 electrons, P 6 electrons, D 10 electrons and F 14 electrons. You must remember these values if you want to write electronic configuration. Just be familiar with these values. So next on we have this chart. So how to draw this? Just remember how to draw this and the pattern which this chart follows. So you first write 1s, 2s up to 8s. Then you don't write 1p. You start with 2p, 3p up to 7p and you don't either write 8p. You can see the pattern, right? The first and the last ones aren't written here. You don't write the first ones anywhere again. The first and the last ones won't be written ever again. So there would be no 1p, 1d, 1f, nothing like that. So now you can see that after the 2p is written, there would be no 3d, the next shell. So now you will, after completing from 2p to 7p, you will start from 3d and you will write up to 6d. What's the difference here? You did not write 2. You did not write 7 either. I hope you are getting the pattern here. I hope you can see the pattern that's occurring here. So after that you go to the F shell. Then you don't write 3F or either 6F. You just write 4 and 5F. You get that? So it just takes a little practice to actually draw this chart. So do some practice. It's not like everybody gets it while they actually see it. Do some practice on how to draw this chart. It's very important actually. So now, okay, you have completed drawing the chart. Now what? So now you'll actually, you know that, right? For example, this is a very common topic actually. If there is a carbon atom, you know that carbon's atomic number is 6. So now how would you place the electrons in each shell? The first electron goes in the first shell, second in the first shell. Remember, the first shell can only contain up to 2 electrons. Okay, the next one up to 8. Yes. So now 2 electrons are completed. Now there are still 4, right? Now you can see that there are only 4 electrons remaining that we need to draw. Sorry. So 1 here, 2, 3 and 4. This is very easy. This is just the basic concept. So you can see that we do not go to the second shell. Without completing the first shell. That is a basic rule of chemistry, that you must complete the inner shells before going to the outer shells. You must. So there might be some exceptions. I'll tell you on that in later videos. So now first you'll complete the first shell and only then will you go into the second shell. Remember that. So now, okay, the basic question is, there are these many shells, but in which one do you put the electrons first? For example, if I have one electron, which is hydrogen, where will you put that electron in? In which shell will you put that electron in? Shall I keep that in 1s? Okay, fine. If I kept that in 1s, if I have 5 electrons, where will I keep that in? Will I just go to 2s? No, there is a certain order actually. This is wrong. There is a certain order actually, and that is very easy to remember also. That is very easy to remember too. So, all you need to do is, you draw some diagonal lines. And you need to draw these lines very carefully. Very carefully. So, you will draw one across 1s and the other across 2s. You can see how it's going actually. So now, why are these lines important? Why are these lines important? First we have drawn this line, second this line, third, and so on forth. So now you can see that first we draw a line on 1s. So the first, if I am given 10 electrons, I'll put them first in 1s. What is the capacity of S shell? Only 2 electrons. So what will I do? From 10 electrons, I will put 2 electrons in S1s shell. Then I'll be remained with the 10 electrons become 8 electrons now. Okay, fine. Now where will I put all these in? So now this is completed, and the second one, the second arrow or the diagonal line goes through 2s. So you keep that in 2s. I hope you are getting it. So now we know that the capacity of S shell is 2 electrons. So now again 2 electrons go into 2s. So now what happens? This 8 electrons becomes 6 electrons. Okay. Now should I go into 3s? No, that's wrong. We need to go to 2p. And why is that so? Here you can see, while you are drawing the line, first you come across, when you draw this diagonal, you come across 2p. So before writing 3s, we put the electrons in 2p. So what happens here? So what is first? Okay, the electrons go into 2p. What is the capacity of p shell? 6 electrons. So what happens here? The 6 electrons. We are remained with 6 electrons after putting other 2 electrons in the 2s, right? So this 6 electrons, what will happen to them? They will go into, the 6 electrons will go into 2p. That's it. We are done with it. So now, okay, we've got this concept. It's a little bit trickier at first, but you'll get familiar with it day by day. So now, how do you write it at all? So this is little tricky at first, but you'll get through it. How do you write it in a single line? You remember the cell configuration? Do you know the cell configuration? Did I say that in this video? Not quite sure, right? So for example, let me draw an atom. I'm very bad at drawing. So now, this is a beryllium atom. Let's make it boron. I don't like it. So now, very good. So now we can see that there are 5 electrons in it. So now as there are 5 electrons, actually the cell configuration says that cell configuration is, I think it's my opinion, I think that the cell configuration is much easier than electronic configuration. How do you write cell configuration first? You will see the number of electrons in the first shell. We have 2 here, so it will be 2. And then you go to the second shell, and how many electrons are there in the second shell? You just write the number. In this case, it's 3. So the cell configuration of boron is 2, 3. It's that simple. So you have just wrote the cell configuration in one single line. How could you write the electronic configuration in the same line, same way? So now let's see this. So first I have given you 10 electrons, right? 10 electrons. The first one has go through 1s, so we'll keep 1s. Okay. Now how many electrons will the 1s take? Here the 1s took 2 electrons, right? The capacity of S is 2. So 1s2. Next 1s1 is completed. Next it went to 2s. Okay, you will write 2s also. What is the capacity of S again? It's 2. Same. So you will put it 2 like an exponential form, but it doesn't mean that there is any exponent there. It just tells how many electrons are there in the particular shell. So this is the shell. This is the number of electrons that are present in that shell, in that particular shell. So okay, 1s1, 2s2. Next, it went to 2p. So 2p. Okay, it went to 2p. How many electrons are there in the 2p? 6, right? The capacity is 6 and it gave all its 6 electrons right here. Okay. So this is the electronic configuration of the atom neon. Neon has 10 electrons, so this is the electronic configuration of neon. Okay, fine. Let's just quickly review with some examples. That would be much easier. I'll take some easier examples this time. So let's make basic elements actually, like the hydrogen and helium ones. So hydrogen has 1 electron. This is the shell configuration. I'll write the cell configuration, and after that only I'll write the electronic configuration, so that you can understand way much better. So shell configuration is 1, electronic configuration. Even if 1s can take up to 2 electrons, capacity of S shell, only 1 electron is present in hydrogen. So what will it do? It will give that 1 electron. So how many electrons did the S shell take? 1 electron. You'll get familiar as we go through few more examples. Helium 2, 1s2. What's the difference here? You don't write the capacity of the shell. You write how many electrons are present in that shell. This value is not the capacity of that shell, but the number of electrons present in that shell. Now there is lithium, whose shell configuration is 2, 1. So what would happen here? In the case of lithium, it will first go through 1s. So 1s2. So 2 electrons are completed. Still 1 electron is there, right, to complete the 3 electrons. So where will it go next? It will go to 2s. So 2s, and how many electrons are left here? 1. So 1. Let's check for I think, have we done with beryllium? No, we aren't. So beryllium, just like that. So 2 in the first shell and other 2 in the second shell, right? Yes. So that gives 4. So what happens here? 1s2, and 2s2. This shell is completed. Fine. Now let's do with carbon. Carbon has a atomic number of 6. 2 plus 4 gives 6. You need to be little familiar with the shell configuration first. If I can, I'll make a video on that too. But first let's complete the electronic configuration. So 2 comma 4. So first the electrons go to 1s. The 2 electrons, the capacity is 2, so it takes 2. Next it will go to, sorry, you should not keep any operating signs in middle of configuration, sorry, 2s2. And as you can see, 2 electrons are completed here, 2 electrons are completed here. Still we have 2 more electrons, right? Where will we keep these 2 more electrons? 2p. We will keep them in 2p. So 2p, 2 electrons, right? 2. That will result in 6. So you can work out with some more examples. Actually, this is just about how to write the electronic configuration of every single element, but there are few special cases where some of these rules change. For example, there's chromium, where there's a little exception in the electronic configuration. I'll explain to you all in the next video. So that's it for today.